Welcome to IT Pro in the Know, the ITProTV webinar series. We'll be live tweeting during the webinar at #ProsKnow. Have a question? Use the GoToWebinar question box throughout the webinar and we'll answer as many as we can at the end. You'll receive a link to a recording of the webinar delivered to your inbox. Questions not answered during the webinar will be answered on Twitter with the #ProsKnow. Now let's get started.
Hello and welcome to IT Pro in the Know, the ITProTV webinar series shot live at the ITProTV studios. And well, let's take a look at our presenters for today's webinar. And the first presenter is me. I'm Justin Dennison. I've been in IT for about 7 years. I have a couple of certifications, an Oracle Certified Associate, AWS Certified Developer, and Certified Solutions Architect. And well, I'm one of the ITProTV edutainers here. And our other presenter is none other than Mr. Don Pizzette. He has over 20 years of IT experience and kind of a, if you think you have one, and well, he's already got it. He's got multiple certifications, Cisco, Microsoft, CompTIA, Google, kind of, smorgasbord, if you will. And he's also the co-founder of ITProTV and one of our edutainers. And what is ITProTV? Well, let me tell you a little bit about it. ITProTV is the binge-worthy learning IT platform that's helping you go further. We have IT training for every stage of your career. Whether you're a budding professional or a seasoned expert, we have something for you. And well, if you've already got CompTIA and Cisco and Microsoft, we still have Apple and Linux and security and some cloud training to help you go further. Our interactive two-host format, it kind of keeps you from lulling, going to sleep. We keep things engaging just to keep you on your toes. And I know how difficult it can be setting up your own labs, finding practice exam materials. We have that as well, and that is just a bonus. And if you're part of a team, and you've been helping yourself out, well, we have team plans as well to help your team go further. Now, I've been talking along about me and Don and what we've been doing here, but Don, I'll tell you what, we should probably go ahead and get started with our top 5 DevOps blunders.
Absolutely, Justin. It's what the people are here for. So like you said, the topic of our webinar today is the top 5 DevOps blunders. We're going to take a look at 5 mistakes that I know I keep continually seeing made over and over again in this new world of DevOps. Previously we had these separate roles. There were system administrators or operations, and you had developers. And now a lot of organizations, thanks to cloud deployments and continuous integration, have started combining the two roles together. And that means that a lot of developers are taking on a role that they're not used to, that's new to them, that's having to get in there and support these systems that used to be handled by separate people. Or the reverse is true. You have system administrators who are now having to deal with development work. And in both scenarios, there's plenty of room for mistakes to be made. Anytime you take on new tasks, new requirements, it always opens that up. So that's what we're going to be taking a look at right here in the webinar. But before I get too far into that, let's start off with a quick poll. What I'd like to do is ask you all what your current experience with DevOps is, and that way I can make sure that I'm presenting in a way that's the most meaningful to you. So I want to build this all around one question. How much training have you received in DevOps deployments, right? And I hope each and every one of you is able to answer with option number 1, but take a look at the options and answer appropriately. Number 1 is, I attended training and I have a good understanding of my responsibilities in a DevOps environment. That's the perfect world, right? You've been given new job requirements, you're trained to do those requirements, and then you get in there and you do them properly. But I think we all know it doesn't always work out like that. Option 2, we've studied independently and have a pretty good idea of what we need to do. All right, that's a little more realistic. Option 3, I'm living life one Google search at a time. And there's no shame in that one, right? If you are thrown to the wolves, this is your new job, sometimes you just have to figure it out as you go, and that's where a lot of people are. And then last, number 4, wait, I was supposed to be trained on this? A lot of people are being exposed to cloud technologies like with AWS, where it's so easy to deploy things quickly and to think, I don't really have to worry about the sysadmin side. Amazon will just take care of it for us, right? So if you're in that boat, go with number 4. All right, I think everybody's probably had enough time to get in there and give us an answer. So, Justin, you're watching the poll over there. Who's our winner today?
Well, it was a pretty close race between 2 and 3, but it looks like most everyone is kind of actually in my same boat. Number 3, I'm one Google search away from probably messing something up.
I'll be honest with you. Even if you're number 1, even if you got out there and got formal training in a position, the stuff changes so fast today that it's really hard to keep up with. And leaning on Google is not a bad thing, or DuckDuckGo, or whatever search engine it is you're using. They all are a great resource. The problem is when we reach out like that, just trying to find an answer wherever we can, we may find an answer that is correct, but not optimal, is incorrect, and exposes us to weakness. You know, there's all sorts of different issues that can pop up when we reach out there and just start kind of relying on random people for that assistance. So we always want to make sure we get the most reliable answers we can. If you are relying on Google, make sure you always get a second opinion on any solution or recommendation that you're finding. But there's no shame in doing searches. It's what most of us do. In fact, I saw somebody once who said technical knowledge is one thing, but search engine knowledge is more important today because your ability to learn and rapidly change. All right, well, with that in mind, let's move into our top 5 blunders. And our very first one, I'm going to call system updates. Now, if you're a system administrator, you know how important it is to keep your systems up to date. That new vulnerabilities, exploits, bugs, just all sorts of general things are constantly coming up. And we need to update our operating systems, our software, and other things in order to maintain them. Now, not everyone has learned that lesson, and a really visible example of that happened last year with the Equifax breach. I think you'd have to be living under a rock not to have heard about the Equifax breach. $87.5 million is what they ended up having to pay as penalties. It's still kind of ongoing. The personally identifiable information of millions of people was disclosed in this breach. And after doing analysis, it was all tied back to a vulnerability in Apache Struts, a vulnerability that had been patched several months earlier, but Equifax had not rolled out the update on their servers yet. It was, as Tech Republic put it, a $87.5 million reminder to apply critical security updates. The whole thing could have been avoided. Now, most people are a little hesitant to do updates, and I know, Justin, we've been joking here in the studio because we have macOS Mojave coming out on Monday. Are you excited?
I'm excited to not hit update or to hit the ignore, which is not necessarily the greatest thing. I have actually been part of a project where someone was like, hey, the server's down. We have this test server for people to interact with. And I go and I look, and it hasn't been updated for like 2 years. And people are like, it works. Don't touch it. I said, no, we need to update it. Unfortunately, that many updates actually cause things to crash. So I understand the hesitance here, but it's not a good thing to actually go about doing.
It's not. And so what you need to do is you need to have some kind of testing environment set up where you're able to test and update in a small deployment before rolling out in production. But you absolutely need to set a timeline. And don't just say, oh, we'll get to it eventually, we'll get to it eventually. Because once these exploits are out there, they're being taken advantage of within days, not weeks, not months, not years. It's days. So you really need to have an aggressive security patching schedule in place. And if you think your cloud provider is taking care of it for you, let me show you an example. A few weeks ago, I just tested this out myself. I spun up an Amazon instance, an AWS instance. I did Amazon Linux, their latest one, Amazon Linux 2. I spun it up, and I logged into that instance and did a quick check, and there was already a kernel update out. Now, the kernel, that is the heart and soul of the Linux operating system. And there were actually a couple of different vulnerabilities that were patched in this one. Really, really important to do. But not even from a security standpoint, just a stability side. There's bug fixes and other things. There's race conditions and things that can get corrected that stop you from having lockups and having a bad customer experience or just a bad you experience because you're the one who has to support this. So don't rely on the cloud vendors to do it for you. You need to set up an update regimen, test the updates, get them applied. It doesn't matter if you're sysadmin or devs or DevOps. I mean, this needs to be done, and it'll help you avoid a lot of headaches.
From the developer perspective, this is when I first started diving into AWS. This was kind of out of sight, out of mind. These are released fairly frequently. The Amazon Linux and Amazon Linux 2, those are kept up to date, but they're only released on a certain day, and then you have to catch up with updates. It was not something that was on my radar when I first started, but I'll tell you, it's something that I try to keep in mind now because I know the importance of it.
Sure, and let's pretend for a moment that I deployed this machine and it was up to date. Let's say Amazon had it perfect for me and I deployed it, was completely up to date. All right, well, within the next day or two, patches start coming out for various support software I might be running. Kernel updates come out practically monthly, so I only have a small runway of time where I can rely on that machine being up to date. After that, it is entirely up to me once you deploy the instance. And I'm picking on Amazon just because that's who I had set up on my computer that day. But it's the same with Azure or Google Compute Engine, any of the other ones. And your on-premises servers are the same way, especially if you're installing from installation media like a USB key. When was that USB key made? Well, that's the last time that OS was updated, whenever that key was made. So you need to get updates in place.
Now, Don, this is one of those things, Docker, Kubernetes, this is supposed to take care of all this. We don't have to worry about this anymore. Is that right?
Well, not really. Like when you deploy a Docker image, a Docker container, it has an operating system image that's built upon. Now, it relies on the kernel of the operating system running underneath it, so that kernel might be patched. But if you package support software in with that container, you're deploying a container that could potentially be out of date, that could have out-of-date tools inside of it or other resources. And it's not just the software updates that come in. This kind of leads us to our second DevOps blunder, which is security and permissions, right? When you're working with something like a Docker container on your own machine, we don't worry about security and permissions all that much. It's right here, it's on my local machine, and I'll just go in the firewall and set it to allow all traffic to go back and forth between the container, and I'll have that console type access, so I have full access into it. Well, when you deploy that technology in production, it's a lot different. In production, the world has access, or at least inside of your company, multiple people have access to it. And any little gap in your armor that's available can be taken advantage of. And we have to protect ourselves from that. And there have been numerous cases where companies deploy, especially cloud technologies, because when you deploy a cloud technology, it's out there, it's on the internet. It's not like it's hidden away in the basement in your own on-premises data center. So for example, FedEx had this. And I'm picking on FedEx because they were the first news article that came up in my Google search, living life one Google search at a time. But there are a number of companies, including the US military, that have all had Amazon S3 buckets exposed to the internet, wide open, not with write permissions, not so bad, but with full read permissions, where anybody could get access to them, right? This article came from, let's see, who was this from? Info Security Magazine. And they featured how FedEx had an S3 bucket, and it contained the personally identifiable information for thousands of FedEx customers stored in an S3 bucket with permissions set for global read access. Anybody could go in there and read it. This isn't like super tech hacker breaks into network. It was person stumbles on random open door. That's effectively what this is. When we create an Amazon S3 bucket, you see a screen that looks like this where the permissions are very, very simplified. You can add user accounts, but those are user accounts that are in AWS, not people outside of your organization. So if you want to share this bucket with somebody outside of your organization, it's really tempting to go right down here and grant public read access. And the assumption here is that we can do what's called security through obscurity. If nobody knows the bucket's there, I can leave the door open, right? If people don't know where my house is, I can leave the front door open and it'll be fine. But there's plenty of search engines out there, like the Shodan search engine, that specifically look for open resources like these. And attackers can find them in a very short window of time. If you have personally identifiable information for your customers, if you have medical data, financial data, intellectual property, any kind of sensitive information, when you store it in a system, it has got to be secured. You have to understand the security settings for whatever platform you're deploying on. I'm showing Amazon S3, right? In S3, it's got this very simple permission screen that really doesn't give you a lot of options. And that's because Amazon doesn't want you to use this. They don't want you to set permissions this way. If you dig into the documentation, the right way to apply permissions on an S3 bucket is to write an access policy. And in an access policy, you can get really specific. You can approve, you can say, I want to give full access to anyone coming from a particular IP address or a particular range of IPs. You can approve that access. And now, just random Joe hacker across the internet can't stumble across your open bucket, even though the bucket is open. You'd be tying them to an IP, or you can restrict them to access credentials. You can restrict the time. You can restrict all sorts of different things if you sit down and write the policy. But if you're new to this environment, if you've been a developer for 20 years, or you've been a sysadmin for 20 years supporting on-premises machines, and all of a sudden you're thrown into this cloud environment, well, you're just using the wizard. You're using the GUI, trying to do things quickly and easily, and you can end up in mistakes. Once you actually learn how the platform works and jump in and start to write those policies, now things become the right way. They become more secured, more restricted. you've got to be careful not to accidentally expose your own data. You're not even making the hackers work for it at that point. You're just throwing it out there and people see it.
Now, I'll tell you, Don, accidentally, that's the one thing, but I'll be honest, there have been times where it's been frustrating to programmatically interact. S3 in this case is used for a lot of things like elastic MapReduce or the storage of transaction records, backups, where I need to collaborate with someone. I've turned things completely public just to make it easy. And, from a developer perspective, security is not always my first thought. I just need to get it done. I need to make it easy. But after seeing some of these stories, Walmart had some transactions that were just in an open bucket. You need to be careful, right? Set up accounts. Use these access policies. There are better ways to grant access to individuals without just going, just open the door, right?
Yeah.
I've always heard locks are not to keep criminals out. It's to keep honest people from just kind of coming in. If you happen upon something and it's just free for the taking, you go, oh yeah, let me poke around in here and see what's going on.
Yeah, people have that sense of curiosity. There have been Pentagon contractors that have done this. It's not a mistake just little companies are making. Even the big guys are making this mistake. It's definitely something that we've got to watch out for. All right, let's move on to our next blunder. This is a favorite of mine called operating system hardening. There's a ton of operating systems that are out there. When we deploy, especially web applications are almost always deployed on top of the Linux operating system, right? But I bet if you gathered 10 developers together and asked them all what their favorite operating system was for deploying web apps, you'd get a number of different answers. Some people are like, well, here, let's test. If I asked you, Justin, just to whip up a quick web app and you had to host it on a platform, what OS are you going to go with?
So originally I would go with Ubuntu, but nowadays I actually stay with Amazon Linux or a Red Hat flavor like CentOS. But it has varied a great deal, and sometimes it's just kind of, I just throw my hands up in the air because it's in a Docker container. What's the worst that could go wrong? Whatever the host OS in the image is, that's fine by me. My stuff works, and that's what's being asked of me.
Well, one of the challenges we have is that a lot of operating systems are not packaged securely from the beginning. And the the people who create these operating systems, they'll tell you that. Like, hey, the software is packaged in a way that works for the most people. But if you're deploying this in production, you need to harden it. You need to start shutting down services you're not using, restricting network access to ports you don't need, because if you don't need those, it's a great way to reduce your attack surface and secure your systems, right? And we continue to see organizations deploying and using non-secure operating systems, either operating systems that aren't intended for production use in the first place, or just good commercial operating systems that haven't been hardened. An example was in the news at the end of, or actually it was the middle of last year, back in June of 2017, Linux malware enslaves Raspberry Pi to mine cryptocurrency. All right, this article really stood out to me because of two things. One, it's a Linux malware. A lot of people say, there's the Mac users say, I can't get a virus, I run a Mac, right? Well, it's even worse in the Linux world. We're like, I run Linux, malware doesn't exist. Well, it does exist, it is out there. And Raspberry Pis are a great way to do a quick DevOps type project. For example, last year I decided, this was a horrible idea, but I decided I wanted to do a synchronized light display on my Christmas tree. So you play some crazy kids music and the lights flash and it's all exciting. So I decided I would throw that on a Raspberry Pi. And Raspberry Pi they don't ship with it, but the default OS that they want you to put on there is called Raspbian. It's a Debian flavor made for the Raspberry Pi. Well, it's packaged for students, for people who are learning. It has a default root username and password, right? The username of Pi, the password of Raspberry, and that's full root access to that Raspberry Pi. It has SSH enabled by default. It has a number of other services that run with root privileges that you would never see on an operating system intended to be used in production. Raspbian is not safe for production. And if you start looking around for other OSs to throw onto the Raspberry Pi, they're all kind of packaged the same way. It's designed as a learning platform, not a production platform. But I can rattle off at least 10 Fortune 500 companies right now that I know are using Raspberry Pis in production, maybe to power display screens in their office or signboards or who knows what. Or maybe just an employee has one as a little project sitting on their desk, but it's on their network, and that's a vulnerable machine. If you expose it to the internet, you're really asking for trouble, and that's what we saw here with this Linux malware that was spreading across the internet, just infecting these Raspberry Pis. I'm picking on Raspberry Pis here, but it could be any Internet of Things device. A lot of IoT devices haven't undergone proper hardening, but it could even just be us that if I want a server to host a web app, and so I throw Ubuntu on there, and I do the full desktop version of it because I want a GUI and it's easier to use. Well, that's all increasing your attack surface, and you need to get in and harden and restrict that operating system.
Now, Don, I will tell you, I've actually seen Raspberry Pis, like a stack of them, run the operating systems for the hosting of the web servers, the database backup, and this guy was like, here's my entire website. You can go to this URL right now, and it's in my home office. But it was a proof of concept. I'm pretty sure this gentleman knew the issues that could crop up. But I will tell you, Don, shutting off ports, actually firewall rules, things like that, that is, when I first started, that was not my purview. I got scared. I locked myself out of a bunch of machines. It was not a good experience for me coming from the other side.
So fortunately, it's not that hard to harden an OS. That's kind of, it's not that, whatever. You get what I mean. It's not that hard to do, though, right? If you're running a commercial operating system, if you're running Red Hat Enterprise Linux, which I love, I think is a great solution for stable web deployments. If you're running Windows Server 2016, if you're running Ubuntu, right? These all have commercial entities behind them. And each and every one of them publish hardening guides like this one. This is right from the Red Hat website. If you purchase Red Hat, you get access to their whole documentation suite. I think you can actually set up a free account and get access to it via their member portal. And they publish hardening guides, how to restrict access to that operating system. And this applies if you're running Red Hat on bare metal, or Red Hat in a virtual machine, or if you're running the Red Hat container images for Docker or Kubernetes, that you still need to restrict access to those machines and cut off services you don't need. Microsoft has similar guides they put out. Canonical has similar guides for Ubuntu. Whatever platforms you're using, you need to look for the hardening guide and follow the instructions in it. They lay it all out. They explain how to do it. It's not that hard to do. If you're running a platform that doesn't have a hardening guide, the odds are it's not really intended for commercial production use. So you need to reevaluate that, especially when it comes to Linux. It's not a matter of, I just want to pick the one that I like the most. I don't get to pick distributions based on which one I like the most. I pick a distribution based on which one I know can be stable and secure and not make my phone ring at 3 a.m. when a website is down or something like that. That's an important consideration we have to have when we come up with deployments like this.
And from a development, from a mindset, when I was asked to do this, it was just lack of knowledge. I didn't know these existed initially, and sometimes, it's just knowing's half the battle, I guess, is the way to go about this. Just knowing that these are available for those operating systems would have helped me a great deal initially.
Yeah, and you bring up a great point, which is if one day you're a developer, and all of a sudden the next day you're DevOps, it's a whole new set of responsibilities that are thrown on your shoulder. And if you don't have even the basic amount of training on it, you don't necessarily know all the different aspects that you need to be taking into account. All right, let's move on to a next one. This one always amazes me, and this has been a problem for years and years, even before DevOps. Performance tuning. If you're a developer and you're creating a web application, you're doing it in a local environment, building it right on your laptop, or hey, maybe you've got a test and staged environment and you're building it there, right? Well, those deployments are not under any real load. What's it going to be like when it's not just you or a team of 10 developers on the server? What's it going to be like when there's 1,000 simultaneous customers hitting that application? Or if the process is running at full steam or whatever? What is going to happen? We need to make sure that we consider the performance aspects of our applications, every bit of it. Remember, when it comes to performance, there's 4 things that we look at. There's the CPU power, how much processing power that we have. There's the RAM, how much stuff we can hold in memory. There's disk I/O, which is how fast we can access and write data to our storage. And then there's network bandwidth. Those 4 things are going to dictate how fast or how slow your applications respond, right? And there are big companies that make mistakes in this area too. Last year, during the Black Friday sales. Black Friday and Cyber Monday, really big sales days here in the United States. With Cyber Monday, especially if you're an online retailer, you need to be ready for the deluge of traffic. It's not a surprise. Everybody knows it's coming. But even big retailers like Target underestimated the amount of load they were going to undergo last year, and their site went down. Now, if you're an online retailer and your site goes offline, how much money are you making? None. And even if the site is just really slow, people have a bad experience. I saw a study once that said if people have to wait more than 3 seconds for a page to load, they're already thinking about the next page they're going to go to. They're ready to move on. So we need to make sure that our users have a good experience when they're visiting the site. We need to plan for the workload that we're going to carry. And this is a pretty common mistake, mostly because when you're developing, when you're creating an application, you don't need a lot of resources. I've seen it a number of times where people get in and they're just ramping up things on test systems, right? Amazon does a great job where when you spin up your EC2 instances or anything else, you can turn on CloudWatch and you can see all your performance, your CPU, memory, network, storage. You can see exactly how it's performing, right? But if you're not watching those values, if you're not looking at them, if you're not trying to forecast what that's going to be like under a production load, it doesn't really help you. And I'll tell you, when I'm deploying something just in test to kind of practice or see if I can get it working, I'll deploy a lot of time using T2 instances, right? T2 micro, T2 small, those instances in AWS, which only have one virtual CPU and usually have a very small amount of memory, right? If you look at like a T2 micro, which I use T2 micros all the time. If you've watched any of the AWS training that Justin and I have created, I almost always use T2 micros. They have one vCPU and they only have 1 gig of memory. That doesn't sound like a lot. But if I'm the only one on the web app, that's plenty, right? And so I can develop and build the whole solution using T2s. But T2s are not optimized. They're not optimized for network bandwidth. They're certainly not optimized for storage. And on CPUs, they do this governed CPU credits per hour system where sometimes you can spike and get access to a full CPU, but normally you don't even have access to one entire CPU with the thing. So they're not designed for production use. But I can tell you a number of companies that have deployed production systems using T2 instances. Well, the T stands for test, not production, right? So we shouldn't be rolling those out. Even if you're doing auto scaling and you're spinning up thousands of T2 instances, on the back end, they are not performance optimized. And you can see that really quick when you start to look at some of the other instance types, because there's compute optimized that have extra CPU, memory optimized, storage optimized, the I instances. These guys will give you disk performance that is through the roof. You can get dedicated input-output operations per second, or IOPS, and you can make sure that you get high-speed access to disk. If you're doing anything with databases, anything with session caching, you're going to need fast storage. The I instances, like an i3, if you do like an i3 extra large or whatever, you will get some really great performance out of that you could never achieve with a T2. It's just not the same on the back end. We have to understand what our application needs, right? If I go back a few slides, if it's a web server, web applications are normally cached into RAM, and that's where they're served up. If it's a database server, databases are typically too big to fit in RAM, and so they have indexes in RAM, but the actual data is on disk. So disk I/O is really important. If it's a file server, network bandwidth is what's going to be important, kind of shipping that information across the network. If it's a application server of some sort that's doing mathematical operations or encryption, CPU is really important. And we have to understand the load each user is going to generate on the system and figure out, forecast what that impact is going to be. So simulated workloads are how we avoid this, how we avoid our sites going down, and make sure that we've planned our infrastructure to be able to handle that load.
And Don, that's one of the things. I've actually had this discussion where I go, oh, well, we're doing some performance monitoring or performance testing, and someone goes, I feel like this is going to be sufficient. I will tell you, initially when I hear people tell me that, I go, well, feelings don't necessarily make me feel better about this whole thing. There are a plethora of tools like Apache Bench or Siege or any of those to load test. Also, I've done this before. I've used T2 micros, used some kind of automation tools, get a proof of concept using T2s, and then when I need something a little more robust, I just change the instance types, and then I can quickly iterate through those. So there are tools that will help us to measure and validate our assertions and forecasts.
Yeah, well, what I always say when somebody says I feel like I'm prepared for this, I usually say I feel like you're wrong.
Yeah. I also feel that same way. It's odd. Empirical data is the only way you can prove it to me.
That's right. All right, so just keep in mind, though, this is an easy mistake to make, especially in the day and age of viral videos, right? Maybe you come up with some product, and on average, you have 1,000 visitors to your site a day. And then all of a sudden, you have some viral video, and you get slammed the next day. Well, you couldn't anticipate that, right? It just happened. But if it's something like Cyber Monday, if you have sales that are built around some kind of cycle, then you can anticipate that, and you can build your workload to support it. All right, let's move on to our final top 5 DevOps blunder. And this one I've seen numerous times. And that's where we deploy solutions without any monitoring or logging in place, or it has monitoring and logging, but we don't take the time to figure out how to use it, right? Cloud deployments especially can be very, very complex with a lot of moving pieces inside of them. And it makes it very difficult to figure out where a problem is. If performance on your website takes a dive, where's the problem? The problem could be your web application firewall. It could be an actual firewall. It could be your network. It could be the back-end servers, the database, the application server. These are all different components in your application. And any one of them could be causing your problem. Wouldn't it be nice if you had one place to go for all your monitoring and logging to be able to see what's going on? It would be nice, but most people don't have that. Most people have monitoring for their firewall, monitoring for their instances, monitoring for this, monitoring for that. And logging is usually just this giant jumbled mess of dumped logs into one place you have to go and sift through, and it's a nightmare. We need to think about that ahead of time. And again, this is a mistake plenty of organizations have made. Tesla got hit with this one, where they actually had it's not considered a breach because well, I guess it is a breach, but the attackers weren't going after customer data on this one. They had their AWS account compromised. One of their developers let their AWS credentials get compromised. I believe it was through a phishing attempt is how they got it. The hackers got into the AWS account, and I know what I thought at first, like, okay, did they deface the web page? Did they get the intellectual property? What did they do? They spun up a ton of Bitcoin mining machines. That's what they did. They didn't go after customer databases. They just said, we're going to spin up as many Bitcoin miners as we can, run up Amazon's bill, maybe we'll generate a Bitcoin or two, and off we go, right? Well, how do you know that happens? If they're not actually breaking into your servers, if they're not compromising data, like if they deface your web page, you know pretty quick, hey, somebody broke into my network because I've got a panda bear on my homepage or something. Like, you know, that's that identifier. I had to cycle through like 30 different things to say there before I got to panda bear. So you know, you see that. But if they're just spinning up Bitcoin mining machines, and it's in AWS, it's not on premises. It's not like you hear fans ramp up somewhere or the air conditioner's running extra hard. Well, you need to monitor. You need to see that, right? To have something in place. We have that with ITProTV, and if any of you watched our distributed denial of service webinar, I showed kind of how that works, where for us, we started seeing a huge amount of load on our site. And the main symptom was that the website was slowing down. But we could see in our API that it was starting to spike up. There was a lot of extra access that was going on there. That was one place to monitor things on our API. There were also the web servers on the back end, which, you know, by the end of that story, I'd never actually looked at the web servers on the back end because the API kind of gave me the hint that I needed. On our web application firewall, that's where we saw huge amounts of traffic coming at us from all over the globe. And once we blocked that traffic, the attack traffic, we were able to see most of that traffic from around the globe was attack traffic. It was all being filtered out by that point. If we didn't have monitoring in place, we wouldn't have been able to see this. We might have assumed, site's running kind of slow. Maybe we need to bump up our instances, right? Maybe we need to scale up. Instead of having 4 CPUs, let's go to 8 CPUs. And all we would be doing is allowing more attack traffic to come in. But by being able to look and recognize that traffic was attack traffic, we were able to filter it out and stop it. Same thing with Tesla. While their credentials did get compromised, at the end of the day, they did notice the extra instances spinning up. Their bill prospector showed that, you know, the bill was about to go up significantly, and they were able to get in there, reset the credentials, kill off the Bitcoin mining machines, and then shore that up. You know, that was an example of how people need to be very careful about their credentials, especially with cloud accounts where you know, you're pretty vulnerable right there. So when you're deploying an application, I know a lot of times the focus is, I need to get this feature working by the 12th of the month, right? We're feature driven. But at the same time, you need to think, all right, after this is deployed, how can I make sure it's still working? How can I tell when it's working right versus working wrong? We need to build monitoring and logging into any deployment that we make. It will pay off in spades.
I will tell you, Don, that's something that I had to be very conscious of, because everybody's like, oh, monitor and logging. That seems boring, but it can save you a lot of money. It can save you a lot of heartache. And really, it's going to help you with some of the other aspects, right? Performance monitoring. Oh, well, that's kind of performance tuning, rather. That's part of monitoring. Hey, what's going on here? And, well, just remember to keep those. And a lot of times, cloud services just have this built in, right?
Yeah, yeah, a lot of times they do. The problem is we're not usually going all in on a cloud service, right? You might have a lot of the functionality in AWS, or you split between AWS and Azure, or your databases are hosted by one company and your web applications are hosted by another. When you split across solutions like that, you can get great performance and additional features, but it becomes harder to monitor, and so we have to consider that. All right, well, Justin, that gets us through my list of our top 5 DevOps blunders. I'd like to go ahead and open up to some questions. I know you've been watching the chat room over there. Do we have any good questions come through?
It looks like we do have a few questions coming in. And, well, Samuel from Quebec City asked, what are some examples of services and ports, besides the GUI, that can be turned off on a Raspberry Pi to improve security?
Sure. So there's a couple of things, right off the bat. One of the number one things that I do is you got to get rid of that Pi account. Everybody knows the Pi account exists and the default password is Raspberry, so you need to change that. But also it allows root accounts to log in via SSH by default, so you'll want to disable that as well. There's also a handful of other services that are on there depending on which distro or which version of Raspbian you're installing, because they've added some additional functionality. There are a couple of write-ups out there on the internet on stuff that you can secure on it. But what I typically do is go into IP tables and turn off everything. Just block everything in the IP tables firewall, and then from there you can just open up what you need. In my case, a lot of times all I need is SSH, and I only need SSH access from my local network. So by putting that rule in place, that cuts everything out, and now you're in business. With SSH, you can combine that with things like TCP filters to restrict down to like which users are allowed to get in there, and do other things to secure it that way as well. Also, I didn't mention it earlier, but on any kind of appliance or Internet of Thing or whatever, never, ever, ever trust private keys that are on the device when you receive it. Because some of the vendors do generate them uniquely for each device, but many of them just deploy an image on those devices, and you'll have the same private key as everybody who also has one of those devices. So you've got to reset that. If you're doing any kind of certificate authentication, don't trust private keys that come on your device.
Well, Don, I tell you what, there's some things I need to do when I get home today. But before we can do that, we have another question, and it's Tom from Washington, D.C. What is the best or most popular language to learn when you're getting into DevOps?
This is a tough one because you hear a lot of people respond with different things. A few years ago, there were a number of people that would say, like, oh, we need Java. Java was a big deal, and then JavaScript kind of supplanted that because everybody went to web applications. But I feel like today, most of the people that are moving in that world are moving in the direction of Python. Python has really gained a lot of popularity there. And Justin, you could probably speak better to this than me because you're the big Python guy, aren't you?
Python does help a great deal. And I mean, you even have tooling that is around automation and immutable infrastructure such as Ansible or SaltStack that is written in Python. Some of those aren't exactly just plain Python, but they would be helpful. I think Python is good. Depending on some of your tooling, you might even need to learn a little bit of Ruby. But it's kind of gotten to where there are some languages specific to tooling. Take Terraform, for instance, from HashiCorp. If you use that as part of your development cycle or your deployment cycle, you're going to learn a HashiCorp specific language, HCL, which is, it's not hard. It looks a lot like JSON, but you're just going to have to pick it up on the go. And then really, I would start with Python. It's going to give you a pretty good foundation. The other ones are just going to be adding to what you know, so to speak. And, well, it looks like we have another question. Ben from Atlanta, what IIS performance monitoring would you recommend?
IIS. So let me clarify here first. I haven't used IIS in a production environment in about 5 years. Pretty much everything has gone Apache and Nginx these days. But when I was supporting IIS servers in production, there was a utility from Quest Software, which is now owned by Dell, but it's called Spotlight. And Spotlight would give you an amazing graphical dashboard where you could see performance. And they had Spotlight for IIS, Spotlight for Active Directory, Spotlight for Microsoft SQL, Microsoft Exchange. So you could monitor those Microsoft platforms. And it was just so nice to have this, it was really a beautiful dashboard to be able to see and monitor that performance. And you could set up alerting and things. Now, I've used that one. Also, SolarWinds makes a network performance monitor and an application performance monitor. And the APM fully supports monitoring IIS, and you can really get good feedback. It can send you text messages, it can send you email alerts, and kind of keep you abreast of what's going on. But you can also do trend analysis with it. It's not the cheapest software in the planet, but it is worth it. Really, the whole SolarWinds Network Performance Monitor is a great solution for monitoring just about anything.
I tell you what, Don, I'm glad you were here for that one, because I would have just been staring at the camera going, that's a good question. I don't really know. Not really my purview. And well, we have another question. Jose from Montreal. It is absolutely daunting, the number of tools and technologies that you have to learn to become involved in any CI/CD pipeline. Any blueprints that you or I would recommend?
You know, for me, I don't have a blueprint that I would recommend, and I would warn you that it's hard to say that there's one blueprint, because what's going to happen is you're going to go to work in one organization or another, and they'll have completely different things they've chosen. You might go one place and they're an all JavaScript and Microsoft Azure system. You go somewhere else and it's all Python and AWS. And so it's hard to say, like, if you learn this one stack, you're going to be perfect. Like years ago, you could go with LAMP. If you knew Linux, Apache, MySQL, PHP, like that was enough to make you a good developer to be able to get in there and do DevOps, and that was it. But now it's fractured so much that people cringe when I say, oh, we need to do PHP development. Do you look forward to that, Justin?
I do not, but I understand this issue. That at previous roles that I've had, sometimes it would change by the week. Like, oh, well, what is going to be our continuous integration solution? What are we developing? Oh, it's Python this week. We need to know a little bit of Rust. Oh, we need Go today. And really, it's about developing a foundation of ideas. It's hard to have a blueprint. It's what are the high-level things that we need to accomplish, right? I need to test. I need to deploy. Do I have manual testing? What languages? What platforms? And to some extent, the things that we've talked about today. Is it hardened? Are we using containers? Are we using Kubernetes? Are we using Docker Swarm? Yeah, there's a lot of technologies, but really, how are we going to deploy? How are we going to test? And how are we going to develop are kind of the core things that I keep in mind.
Yeah, and I would caution you not to be too ready to jump on the latest and greatest languages when they come out. You know, you rattled off several. I know Rust was supposed to be the second coming of development, and it really hasn't become that. With companies, a lot of times they don't want to try the latest and greatest because it's hard to hire people that are trained in it. If they need to hire a developer, it's much easier to find developers that are in the tried and true languages. I can find JavaScript developers pretty easily. It becomes really hard to find a Haskell developer or somebody in a more of a niche language, even though the language might be better for my organization. So I wouldn't focus too hard on trying to nail down one stack or one perfect solution, because this is really not going to be a perfect one.
I can actually mirror that. I like learning new things. It can be a little overwhelming, and if it's part of a job role, you're like, well, what do I do? What do I do? Maybe I'm an imposter. I'm going to get fired. But really, as long as you have an open mind, you have those high-level concepts in mind, then learn what you need to learn as you need to learn it.
Just learning syntax at that point, right?
Yeah. It's just, oh, I need to change this. There's a few things, Rust being one thing, a little mind-bendy when you first get started, but not too bad. And, well, we have another question from Michael or Mikhail. I'm sorry if depending on the pronunciation there, from Scottsdale, Arizona. What are some of the courses on our site that he should start off with? I'm new to SysOps for about 5 to 6 months.
All right. We have several episodes that focus on things like security and performance. I know I mentioned Red Hat Enterprise Linux, or RHEL. I like Red Hat because it's stable and there's commercial support. If something goes wrong, I can call Red Hat on the phone. We have Red Hat training on our site, so you can go and learn about how to properly deploy it, how to secure it, some of the different features that are found inside of it. If you go to our course library and search for hardening, you'll find where we have episodes on hardening several different operating systems that are out there. I know I've done more than one on Linux. We also have cloud training, like on AWS and Azure. Our Azure training is larger than really any of our competitors. It's an impressive amount of training there. On the development side, Justin, you can speak to that, right?
Development, we have a lot of introductory courses. If you're looking to get started with Python, well, we probably got you covered. I tend to take small little chunks, like, hey, here's the basics of the syntax and some data structures that you need, and then kind of build upon that. But we also have web development, Node.js. We have a little bit of Java training, but it's really to get you started, to make you feel comfortable, and then our higher level ones are actually cloud specific kind of things.
Yeah, and, we're actually filming right now AWS Certified Developer, and we're going to be starting AWS Certified DevOps Engineer soon. So if you sign up for a free account, you can watch live and catch us as we start filming that. I think filming for it starts again on Monday, doesn't it?
I believe so. Definitely check the schedule. It is busy times around here. And it looks like we have another question here. Tyler is asking, what are some good monitoring tools for a multi-OS server environment? And, well, really, are the free tools good enough, or should I be paying for something?
You know, there are some free tools that are out there. MRTG pops to mind as a big one, and you can use it to monitor just about anything. I will tell you that most of the free monitoring tools like Zabbix and MRTG, they're pretty hard to get deployed properly, and their agents aren't always the best supported. You can do it. It'll work. You can even use some of the older protocols like SNMP, but it's getting more and more dangerous each year. A lot of operating systems are removing support for SNMP, and it's not the most secure protocol in the world. So the commercial products that are out there are expensive, but they're worth it. You can get solutions like What's Up Gold, which is fairly inexpensive in the general scheme of things. There's SolarWinds Network Performance Monitor. It's more expensive, but is really good, and you can be up and running in like a day. You can go really crazy, do like Microsoft System Center's Operations Manager, IBM Tivoli. There's products like that. CA Unicenter. If you got a few million in your budget, CA Unicenter can monitor anything, but it costs millions of dollars. So the solutions are really across the board. If you are just trying to learn what it's like to do multi-OS monitoring, you can do like a free eval copy of SolarWinds. That'll certainly work for you. But on the free side, I probably would say Zabbix is one of the better ones. There's Cacti, MRTG, PRTG on the Windows side, and a handful of others that are out there that are all useful.
I tell you what, that's a great deal of wonderful information. And if you've liked what you've seen today, then an ITProTV membership is definitely something you should check out. You can check out our free membership with no credit card required, with access to selective courses and our daily live feed. You can also get a full membership that provides full access to our course library, with or without practice exams and virtual labs. And if you're on a team, you'll want to check out our Teams page online, which offers a tour of the Pro Portal, which is used to maximize your team's investment in training. That's itpro.tv/4teams. And remember, since you've been part of this webinar, remember that coupon code, webinar30, to help you get started. And well, Don, I think that's going to finish it up for us. So we're going to go ahead and get out of here. So signing off for ITProTV, I've been your host, Justin Dennison.
And I'm Don Pizzette.
And we'll see you next time.
Thank you for joining us today. You'll receive a link to a recording of the webinar delivered to your inbox. All of the questions we didn't get to will be answered via Twitter at #ProsKnow. Remember that coupon code is webinar30. See you next time on IT Pro in the Know, the IT Pro TV webinar series.